Hey guys, we're going to talk about find the derivative of a natural log and how hard and or easy it could be depending on your approach. So as you see here, I'm asking you to take the derivative of a natural log of an x times an x squared plus 1 that is squared. All of that gets divided by a 2x to the third minus 1, which is being square rooted. This one screams chain rule right now. And there's a quotient, and there's a product, and there's a radical. Yeah. Um, but if we're clever and we can think about rewriting it, we can actually avoid all that. And here's how we would do that. When I see multiplication or division or powers inside of a logarithm, I can use my logarithm properties to expand this if need be. So I can think about this as natural log of an x times an x squared plus 1 squared minus the natural log of 2x cubed minus 1 to the half power, which, because those are being multiplied in the first natural log, I can expand that even a little further to make it natural log of an x plus natural log of an x squared plus 1 squared minus 1/2 natural log of 2x cubed minus 1. And last, final touch, I can think about this as natural log of x plus 2 natural log of x squared plus 1 minus 1/2 natural log of 2x cubed minus 1. If I do it this way, I don't see a need for a product or a quotient rule because there's not really any multiplying or dividing of terms. I can just see a little bit of chain rule and a little bit of a power rule. So let's do it. So if I'm taking the derivative of this expression instead, well, piece by piece, this part will turn into a 1 over x. This part is 2 times 1 over x squared plus 1 times a 2x, because that's where the chain rule kicks in, because the derivative of this inner function gives me the 2x minus 1/2 times 1 over 2x cubed minus 1 times 6x squared, because again, derivative of the inner function produces that. So then, cleaning it up a bit, I get, I have 1 over x plus 4x over x squared plus 1 minus 6x squared over 2 times 2x cubed minus 1. And the last little thing I can do to try to simplify this is, well, I mean, I could try to rewrite them to have common denominators, but I don't see my answer getting a lot simpler after that. So I would just clean up the fractions a little if I can, and doing so gets me this. So this is what my final answer would be. No chain or no product quotient rule needed. The end.